Okay, our next speaker will be running his presentation. He's Paul Ruvolo, Olin College of Engineering. Paul, can you hear me?
I can. How do my slides look?
They are coming. I see them. Great. I think we're good.
All right, fantastic. All right, thank you so much for the introduction, and my apologies for not being able to be there in person, but I am really excited to be able to participate in this this conference. So I think the previous two talks really set up a lot of what I want to talk about, and there's a little bit of overlap, but I think I'll bring some new dimensions. My talk is called Augmented Reality Technology for Navigation. And the main threads I'm going to focus on, I'm going to go back a little bit and talk about the history of assistive technology for folks who are blind or visually impaired, but with a particular focus on navigation technology. And then I'm going to follow that thread forward and say, how can the emerging segment of consumer level augmented reality devices and software, what new opportunities are they opening up in this kind of space of assistive navigation technology? So once we've kind of discussed that ground, I'm going to talk a bit about what that intersection looks like. What are some of the work people are doing at the intersection of navigation and assistive and augmented reality? And then I'm going to conclude with talking about how this work could be kind of scaled up to a wider audience. So how can we actually get this stuff out of the lab and get people using it in the real world? All right, so let me see. Okay, so I guess this probably goes without saying, but I wanted to start with this idea that we live in an inaccessible world. So access barriers are created due to careless or bad technological design, and access barriers can be created due to people overlooking the needs of particular segments of the population. And so I wanted to start by saying that just to frame the idea of assistive technology not as fixing broken people, but as fixing broken environments. And so on this slide, I have two examples of that. Of course, there's things like cases where ramps weren't put in a certain place, making them inaccessible for folks in wheelchairs or other folks who have mobility challenges. And then, of course, our favorite, these flat screen, touchscreen based sort of appliances that are very difficult for folks who are blind to access without any additional technology. And so human adaptation can go a long way. So, despite these access challenges, I think it's important to start with this idea of competency and the sort of celebrating like individual adaptability to performing tasks. So on this slide, I have a picture of a blind man standing at the corner of a street. It's a very chaotic scene. There's a lot of sort of people milling about. And whenever I show this to my students that I do work with and ask them to say what they think about this image, they always say things like, oh, this guy must be really scared, or this guy must, have a very difficult time kind of navigating this environment. And I always kind of point out that, with individual adaptation and training, the accessibility gaps can be, overcome to a great degree. And so there's a lot of importance to sort of acknowledging that before talking about the role of technology and what role that could play in this kind of ecosystem. So despite that, I do want to say that technology does have a role to play. So just like technology makes everyone's lives easier, it can have the same effect in the case of assistive technologies for folks who are blind. So technology can make certain activities easier, more pleasurable, more efficient, more fun, et cetera. All those things are possible. And in fact, folks who are blind have a really long history of using technology. First of all, you can think of the mobility cane itself as a type of technology. It is, exquisite for the purpose that it was designed for, and can, with skillful usage, can perform a lot of orientation mobility tasks, sort of the bedrock of that skill set. And then, of course, in the high-tech realm, so folks who are blind are typically among the earliest adopters of new and emerging technologies. So talking about things like optical character recognition for, reading documents, or GPS-based navigation systems, laser sort of depth sensing or sonar systems for sensing obstacles. These were all things that, came into the mainstream later, but really had their first usage by consumers in the world of assistive technology for folks who are blind. Let's see, next slide. All right, so now I want to go into a bit more detail about the area of assistive technology. I'm going to focus primarily on the idea of navigation technology, so kind of moving away from the more general case. And so there are quite a few technologies in the space of assistive navigation technology. I'm going to briefly summarize a few of the main categories, and then I'm going to drill down more into the area that I work on, which is wayfinding. So the first kind of major area that you kind of see work on in the space is the idea of obstacle detection and avoidance. So some of the earliest examples of sort of high-tech solutions being brought to this area of assistive tech were these like cane replacements that were developed. I'm not sure when the first one was, but it might have been like the 70s or so, or even earlier. And the idea there was like, how can we, improve on the cane? So the cane is great, but there was this idea that maybe we could make it better by replacing with some sort of technology. That sort of approach has really gone out of favor for good reasons. There's a lot of things that are great about having a piece of technology that is not going to run out of batteries, like the cane is really robust and really should not be replaced by these advanced technologies. But one area where there is a role for technology to play, or has sort of gotten a lot of traction, is this idea of detecting obstacles that are above waist level. So there's been a number of products in that space. So on this slide, I have 4 such examples. I have a device called Sunuband, which uses ultrasonic emitter to detect reflections and then give you a depth estimate. And the idea is you wear it as a wristband so you can get information about chest high obstacles. There's also Buzz Clip and a couple other ones. So there's WeWalk, which is a cane that has this technology integrated into it. And a more modern version is called Aura, which is a LiDAR-based version of that. Okay, so that's one area. And then the other major area I want to talk about is wayfinding. So I really enjoyed Brandon's talk, and he did a great job kind of positioning this as a particular area for technology and AR technology in particular. So historically, for folks who are blind, if you talk about wayfinding and you think about the idea of getting maybe GPS-based directions, that was typically done with special purpose devices. So on this slide, I have a picture of the Trekker Breeze, which is one of the devices that's used. Nowadays, a lot of this happens via smartphone apps. So leveraging the fact that most folks have a smartphone on them sort of at all times and using that to provide this capability without a special purpose device. Most of the technology is for outdoor navigation, but some of it can be for indoor navigation. So there's a few systems based on Bluetooth beacons where you can install those in a venue and get directions. I'm going to go into more detail about the other place where you see indoor navigation, which is in augmented reality. So I'm going to save that for later. Okay, so in this slide, I want to focus on what are the kind of current mainstream platforms for augmented reality. Certainly there's many kind of research grade tools, or sort of like things that are kind of not widely available that you might build systems like this on. But I wanted to talk about kind of like what are the things that can kind of get out to people that they kind of have right now. Like it's not Apple. I have Apple Vision Pro on this one, which nobody has yet, but that one might be coming. That will be coming next year. So of course, the first one to talk about are smartphones and tablets. So we have things like Apple's devices have a library called ARKit, which gives them a lot of really advanced augmented reality kind of tools. For Google, we have ARCore. And in the headset form factor, we have things like HoloLens or the Meta Quest or the Apple Vision Pro as things that are kind of coming out. I really like what Brandon said about this misconception that AR and VR is all about seeing. I definitely agree that it's not. And so I did put headphones with head tracking as another sort of type of AR device that's built around an auditory experience rather than a visual experience. So all of this technology that's coming out from sort of the big tech companies of the world gives a rich kind of starting point for the development of new assistive technologies in the AR space. And that's really the area that I've been kind of exploring in my research over the last few years. Okay, so what are the key components of an AR system that makes it useful for creating assistive technology for navigation? So probably the first thing to mention is the motion tracking capabilities of augmented reality systems. So if we talk about something like a phone that is like an iPhone that has ARKit, it's going to be estimating its motion through space using a combination of visual and inertial sensing. So the visual part would be taking pictures of the environment and looking for areas of the environment that can be tracked through multiple frames to try to sense the direction of the camera motion, and then combining that with accelerometers and gyroscopes to understand the motion of the person. It's important to emphasize that this technology gives you a relative motion estimate. So it doesn't tell you where you are in sort of an absolute sense, like you would get from something like GPS, but it does give you a sense of how you're moving relative to some initial starting point. These technologies often do have some visual mapping built into them. So the idea that you can record an environment by capturing images and sort of extracting the 3D position of salient features in the environment. And then when you come back to the environment, you can match images from the device to the saved map in order to reposition the user in the environment. And then the final major capability is the ability to detect features in the environment. So things like doors or walls or signs. These are all things that augmented reality technology is doing, because to sort of provide good AR experiences, you have to have a sense of the sort of objects in the environment so that virtual content can interact with those objects in a realistic way. So these are sort of like the kind of baseline technological capabilities. And then when you kind of bring that over to use cases, we talk about sort of technology that might be relevant to folks who are blind or visually impaired. You get things like wayfinding. So most of the wayfinding technology is for outdoor use. The visual inertial tracking gives you the potential to bring it indoors. Also things like obstacle detection and avoidance. So maybe these newer technologies can help with an enhanced version of that. Detecting signage, so things like knowing when you're able to cross the street by getting some feedback there, or mentally mapping one's surroundings, sort of getting some description about what is in the environment and building that sort of situational awareness of maybe who's around you, where the sort of doors are, where the furniture is, all those types of things. Navigation simulation. So this is maybe kind of on the same vein that Brandon was talking about with the sort of cane troller idea. So kind of giving the ability to kind of preview navigating a particular scenario. There's also a lot of usages for folks who have low vision. I'll defer that one to the next talk. I'm going to focus mostly on this talk on the idea of wayfinding. Okay, so let me talk a bit about the current kind of AR technology for wayfinding. I'm definitely leaving out some technology here, but I wanted to just give a kind of what I think is a fairly representative lay of the land in this environment. So currently, most of this technology is app-based. Sometimes there's a companion hardware peripheral that can be used alongside of it. And the key challenges and differences among these different solutions are things like positioning. How do we determine where the user is in order to give them guidance along some sort of route? How do we convey spatial information to help a user navigate effectively and independently? And also kind of the coverage area. So how do we actually get routes into these apps in the first place? Where do they come from and who can contribute to them? Okay, so I'll talk about each of these on the next few slides. All right, so the first one I want to talk about is Navilens. So Navilens is a Spanish company, and they have a proprietary tag system. So on this slide, I have a picture of one of their tags. It's sort of this brightly colored checkerboard kind of pattern, and it's attached to a bus stop. I think this one is in Canada somewhere, I believe. And the idea is that somebody could walk up to this bus stop, they can point their phone at the tag can be picked up from about 40 feet away or so, and there's a database of basically the particular pattern they're scanning and like kind of where it is and like what's there, and you can kind of move towards the object and get updates as you get closer. They also have a kind of interesting partnership with Kellogg's. So this is in Europe, they have the tags on cereal boxes with the idea that people could find the cereal more easily in the grocery store or maybe even at home. I think mostly for the grocery store. They also have a personal routes feature where you can take these tags, put them up in some environment and record a route from some point in the environment to another point and kind of save that on your device. You can navigate it again later. So it's really designed around the idea of using these tags as kind of location markers that can then be used to anchor routes onto. Then Good Maps Explore. This one is using a different approach. So instead of having the user record the routes themselves, Good Maps Explore, the idea is for somebody to come to your environment with a really sophisticated 3D mapping tool. So on this slide, there's a picture of somebody wearing a backpack with a bunch of cameras and LiDARs on it. The person can go through the environment, capture a bunch of imagery, and also create a 3D point cloud of relevant features in the environment, like stairwells and doorways and things like that. So Good Maps is a kind of a spin-off of American Printing House for the Blind, and they have a business where they basically charge venues money to map their space and make it available on the app. So I checked the other day, they have about 127 buildings worldwide that have been entered into the thing. Then when the user comes to the venue, they can just use their smartphone to localize to the environment and get directions to points of interest. Seeing AI, many people might know Seeing AI because it's sort of a Swiss Army knife for accessibility. It's able to do a bunch of things like text recognition and the like, but they have added support recently for personal route recording. So the idea that you can use your phone to record kind of a visual spatial map of your environment as you walk to a particular location, and then store that so you can use it again in the future. So this is a little bit different than the NaviLens approach because they're using visual markers rather than the sort of special purpose signage that's used in NaviLens. I also want to talk a bit about the iNavigate app. So this is one that James Coughlin's group's been working on at Smith-Kettlewell. And so they're taking a similar approach in that they're using ARKit for kind of motion tracking. And they're building a lot of intelligence into the app to detect various types of landmarks in the environment. So they're interested in detecting signs, particular exit signs or other sort of salient signs in the environment. And if you have a data set that shows you where those signs are, you can use that to sort of position the user within the environment. And they've been doing a bunch of work on how to quickly localize people and also how to help people position their cameras correctly so they pick up these signs. In my group, we created an app called Clew. This was sort of one of the first apps that went out to the mass market and enabled people to record their own routes. So our app, when it came out, was a little bit simpler than some of these later apps. We've since kind of extended them. But the app's been downloaded about 20,000 times and used by about 700 users a month. So we focus a lot on sort of usability in our work. How can we help people to record these routes in a way that is easy to do, and also to give feedback in a way that is robust to things like how people hold their phone relative to their body, and how people, how much kind of guidance people want versus just being able to kind of keep their senses free and kind of looking at the environment. We've also focused a lot on creating tutorials and things of that nature. More recently in my group, we've been creating a new application. We don't quite have a name for it, so I'm going to call it Step Navigation. Currently, we're working with an online group of 30 folks from around the world to test this app out in a program we call our co-design program. This application is really designed around the idea of having kind of a community curated set of routes that people can record and upload so that other people can follow them. We're trying to move away from the idea of routes to the idea of maps. So you can have sort of anchors that mark potential starting points and destinations for navigation, and then you can connect them together using your phone. And as you start to connect these paths more and more, you get this sort of dense network of navigable spaces in a building. And you can sort of anybody can take out their phone, find the anchors that are around them, and navigate where they want to go. So that's the technology we're in the middle of creating. We're also interfacing with some cool technology that Google has now, where you can use the street view data that they have of the environment in order to position yourself outdoors. And so that gives you some really nice opportunities to connect maps up to their kind of precise position in latitude and longitude and enable seamless outdoor to indoor navigation. Let me just do a quick time check here. Okay.
You have about 1 or 2 minutes.
Okay, sounds good. All right. Let me wrap up a bit then with a little bit of the idea of how do you get this technology out into the world. So one of the challenges of this kind of work is it definitely really kind of straddles this boundary of academia and industry. So what I've realized in my work is a lot of the work you need to do to actually make this technology ready for folks to use in the real world is sort of out of the scope of what can be done in the course of academic research. So oftentimes these are like, really practical issues or usability, tuning the usability of apps, things along that nature. So it really leaves this major question of how do you get funding for this type of work to make it sustainable, so you can continue to do it. So this is really where I'm focusing now, which is like thinking about how do you actually take this to the market. So there's a couple of different ways. This is not going to be anything revolutionary, but of course you have a direct to consumer model where end users might pay for the technology. That's a pretty difficult one to work with this particular market because the market's relatively small. So that's one thing. The only people who've really made that work have hardware products that cost, thousands of dollars. The other way that people are kind of pursuing this is to charge the venue. So the idea that you can make a venue accessible and you can charge them for that service. So that's sort of the way that Good Maps model works, and also sort of these beacon-based technologies. So that's kind of where I'm at. I guess the other approach is sort of a grants or kind of philanthropic model, where you're kind of continuously kind of trying to get funding to support the work through those kind of avenues. All right, so with that, I'll kind of wrap up. So just thank you to my funder, the National Science Foundation. And I think there's a lot we can do as researchers to influence the creation of this technology. And I really welcome questions or any inquiries via email if you have any interest in collaborating or asking more questions after the talk is over. All right, thank you, everybody.
Thank you so much. Thank you very much. I see I've been neglectful of the Zoom chat, and I see that we have a Zoom chat question.
I see that.
This talk. Can you? Oh, okay.
I'm just reading through this question. So it says, do you have anything for navigation except the conventional mobility folding cane? So I think the question is this question around like, what could this technology be a mobility tool for folks in that group?
Right, and maybe part of the question could be, there's the use of a tool like a navigation tool to get from A to B, but there's also the use of it as a training tool. Maybe an O&M shows you how to use.
Sure. Yeah, absolutely. Yeah, I have worked a bit on that. I think there's some work in that space. We created a system to do tracking of the cane, I guess similar to like this kind of cane troll idea, but with a sensor you can like take on the go to get feedback about how you're kind of moving your phone, your cane around. So I could imagine it could be part of that training. But yeah, the feedback can be made to be accessible for folks who are deafblind, also using things like tactile feedback and that kind of thing.
And I will hold mine. Okay.
Getting a lot of kind of crosstalk on the line.
You know what is room right here, right?
We are trying to mute.
I will be around.
Yeah. Can you all please be remote at the moment, except for Paul?
Okay.
Thank you very much.
All right. Well, is there any other questions in the room at the moment?
Well, I don't see any questions. Oh, hold on. Gabriele has a question.
Thank you. Very nice presentation. And I'm Gabriele Galimberti from University of Milan. And I think that, what do you think about the safe of those systems in real environments? Are those systems that, how much are safe for a person with blindness to navigate in an environment?
Yeah, that's definitely a lot to that question. So as we work with the people in our co-design program, there's been a lot of questions around like, if I'm going to follow a route that somebody else created, how can I build confidence that it's going to actually kind of take me where I want to go? And so that does bring in this whole idea of like, how do you vet these routes? How do you kind of do quality control? How do you build that kind of model of trust? And then additionally, there's sort of this idea that like this type of technology is never going to like work 100% of the time. So there's always going to be, the possibility that like the tracking won't work perfectly in an environment because maybe the lighting or something has changed in the environment. I mean, I've definitely, in terms of safety, I kind of maintain this idea that the user has mobility cane, and that is sort of the bedrock of safety in this. And I've kind of taken a view that folks can be trusted to kind of maintain their own kind of situational awareness and safety in an environment. That's my personal kind of view on it. I guess other people might take a different view and say the technology would have to work 100% of the time before you even let anybody try it out. But I've sort of said, lots of these technologies are not 100%. People use them, can derive benefit from them, and can responsibly use them and be safe. So that's where I personally land.
Any other questions? Roberto, I can't believe you don't have a question. No pressure.
Oh, Roberto's there. That's great. Yeah.
Do you have one? Okay, let me give you the mic.
James. Thank you, Paul. Excellent talk. Very nice. I just want to follow up on the safety question. The guide dogs for the blind here in San Rafael, they have a rule that as a blind person, as I understand it, you're not going to be assigned a dog unless you're already an independent traveler. You need to be a good cane user, and at that point, you'll be able to get a dog. And I wonder whether something similar can be said about here. That is,
Yeah.
if you are going to be a user of a wayfinding technology, chances are that this technology will work and will be safe only if you're already an independent traveler of some sort, right? And I wonder whether you agree on this. And I guess my second point is, in my experience, a lot of people who are blind, especially if they became blind later in life, they're not independent traveler for multiple reasons. In some cases, they just don't need to be because they have their partner walking with them, or some cases they don't want to be, they're too afraid or other. And so I found this to be unfortunate, because I believe that being able to travel independently is a very important part of living in this world. So I see these two conflicting things. One is that I am expecting that these systems, at least for the way they work, they need to be used by somebody with a good experience. Then again, we would really like to increase the number of folks who are able to go out in the world. So I just wanted to hear your comments on this.
Yeah, I mean, I think you really hit the nail on the head. I mean, I definitely agree that for someone to use an app like this, that they really should be an independent traveler. Yeah, I don't know. Maybe the way to bridge that gap is to think about tools like this as, improving people's ability to travel independently without, these types of apps. That's an area that I definitely have a lot of interest in. But I definitely do see, like, when I work with folks, there's sort of definitely a group of folks who've kind of just lost their vision, and they really view these types of apps as a way to avoid learning how to use the cane. And I think that's one thing where I definitely don't want to sort of be kind of I don't want to dictate how they use the technology, but I also kind of think there is an element of just, it is very useful to have this kind of baseline skill set. So yeah, I don't know. I think you've really put it nicely. And I do think it's a difficult kind of thing to reason around. But has some exciting potential challenges and projects going forward, I think.
Okay, thank you. I think that's all the time we have. Thanks again, Paul. Great talking.
Okay, thank you so much.